All right, so here is our final chapter for organic. We're going to talk about amines and amides. So just a little review of the difference between an amine and an amide. So an amine functional group is a nitrogen and however many hydrogens needed coming off of a carbon. It could even be sandwiched between another carbon, okay? An amide is a functional group that's a mixture between a C double bonded to an O. I don't know why I'm blanking on this one. An aldehyde or a ketone. All right, so it's a C double bonded to an O in addition to being bonded to an N or a nitrogen, and however many hydrogens are needed because it can bind to either another carbon or it can be terminal. Doesn't matter. So amine, just a hydrogen. Amide, hydrogen directly connected to a carbon double bonded to an oxygen. So properties of amines. Amines and amides, they're more soluble, higher BP, higher melting point than alkanes, alkenes, alkynes, but they are less soluble, lower BP, lower MP than alcohol and carboxylic acids. So if we were just to review everything that we have talked about so far, we have alkanes, alkenes, alkynes down here. This is increasing boiling point, melting point, solubility. Right, we have alkenes. We have esters and ethers, which we didn't necessarily talk about. We're going to throw them in there. We have aldehydes and ketones. We have amines and amides here. And then we have alcohol and carboxylic acids. Okay. So that's where we're at, all relative to each other. So naming amines. All right, so we've seen this slide. So we have amine is the suffix for anytime there's an amine group. All the rules still apply. We want to put the carbon connected to the amine at the lowest level, make him the star of the show. So here's the amine. So I'm going to number my carbons 1, 2, 3, 4. So I'm numbering right to left as opposed to vice versa. So I know that my suffix is going to be amine. It's going to be, since there's 4 carbons in the parent chain, it's going to be bute. And because there's no branches or anything coming off, I don't need to worry about my prefix. And so the full name, oh, I need to tell the audience what carbon the amine group is coming off of. If I don't tell the audience, then it's assumed that it's 1, but it doesn't hurt us to put this 1 here. So 1-butamine. All right. So I have some other examples on the next slide. So these examples are already named for us, but I'm going to count the carbons so that way we see. 1, 2, 3. Oh, you know what? I just realized I made a mistake in this last slide. The ending is an amine, so this would have been butanamine. My apologies. All right. So, oops. So 2-pentamine, pentanamine, 2, 3, 4, 5. All right, so we're gonna number right to left because this is the amine group. We want to put him at the star of the show. So anamine, because there's an amine group. 5 carbons, so pent. And then we're telling the audience what carbon that amine group is coming off of. Okay, no branches or anything else, so we don't have to worry about that. Here, I'm going to number the carbons right to left again because I want to make the amine group the star of the show. So I have 4 carbons in my parent chain. So anamine, because there's an amine group. Bute, because there's 4 carbons in my parent chain. 1, because my amine group is coming off that first carbon. And now we have a branch coming off of the 3rd carbon here, which is a 1-carbon branch, so it's methyl. So 3-methyl, 1-butanamine. Now here comes a fun example. So here's our amine group, but he is attached to a methyl group as well. It still makes him an amine group though. So if I number to make him the star of the show, again, butanamine coming off of carbon 2, but I need to address this methyl group. So we say N when it's coming off of a methyl group. Or I'm sorry, coming off of the amino group. So we have a methyl group coming off of the nitrogen, so it's N-methyl-2-butamine. And I believe Al likes to throw in a lot of examples with the not functional group, branches coming off of the amine group. All right, so for your owl, you have to draw for this one. I think this is your question 4 or 5. I don't know. I'm gonna go into owl here. I tried to avoid all the drawing ones in owl because they're kind of confusing, but there was no other examples for just normal amines, and so I left it in. So you only have 1 drawing. I'm gonna do probably 2 examples here because the drawing is difficult. So let me switch over here. That's not what I wanted. Come on. All right. All right, so your question 4 is a drawing. All right, so when I just go in the student view here, this is what pops up as my first example. So 2-methyl, 1-propanamine. So I highly recommend that you draw this on a piece of paper first. I'm going to draw it in the white space beside. Just get your ideas straight. That's my best advice. And if you're having trouble actually drawing it, then you can bring me that drawing, and we can work from there. All right. So I know I'm going to have an amine group. I know it's going to be on the first carbon of 5. So I'm going to go ahead and draw out 5 carbons. Oops, this would be 2, 3. So now it doesn't matter when I am going from name to drawing, it doesn't matter what I choose to number, left to right or right to left, because I could flip the structure and it would be the same, if that makes sense. So when you're going from name to drawing, it's easiest just to number from left to right. All right, so my amine group is coming off of here. And then I have a methyl group coming off of the 2nd carbon. All right. So drawing in owl is complicated. So it's going to take care of all the hydrogens for you. Okay. It's going to automatically adjust. You put in carbons only by starting off of this CH4 here. And then you add heteroatoms by replacing those carbon atoms with the heteroatoms. Okay, it is confusing. That feature we won't need. Okay, so we should only really need this and then this. So I'm going to choose the line tool and I'm going to jump off of this and I'm going to put myself a 5-carbon chain. 1, 2, 3, 4, 5. And I press the carbon in order to grab myself another carbon. And you see here, I'm going to hit the undo. I don't need that one, but just for the sake of showing you. Okay, so now I want off of my first carbon a amine group. So I have to pretend first like it's a another carbon, and then I go in here, I choose N and I replace that carbon. And again, it will automatically take care of the hydrogens. All right, so we've taken care of that. 1, 2, 3, 4, 5. Okay, just double checking. All right, so now to add my methyl group, I'm going to go in back to the line tool and hit off of my second carbon, and it's going to throw it up there. So, oops, that is my structure. An error has been detected. Oh, prop is 4. Oh my gosh, prop is 4. My bad. Let's erase this last one. Wait, is prop? Prop is 3. Monkeys eat peanut butter. Prop is 3. Okay. Wow. That is so sad. All right. There we go. Okay, let's do another one just because these are tricky. Ooh, it gave us a ring. This is a good example. Okay, so cyclohex and amine. All right, so cyclo, we know it's a 6 hex. Okay, so cyclo, we know it's a ring. Hex, we know it's a 6-membered ring. And then anamine. So whatever I decide to be the number 1 carbon means it has an amine group coming off of it. All right, so we have this fancy ring tool where if I press that and then I press this carbon, it automatically gives me a ring. You can try to build it with this tool, but if I remember right, it's really hard. All right, and then I'm going to go in there and press this, give myself another bond, and then override that with my nitrogen. There we go. And again, see, I can make any of these carbons the one with the amine group, because when the audience goes to name it, they're gonna name that as the number 1 carbon. We're moving fast to these, so why not just do another one? All right, so prop again, 3, Kayla, 3. So I'm gonna draw myself a 3-carbon chain. I have the methyl. Ooh, this is fun. I have the amine group coming off of carbon 2 as well as a methyl group. All right, so now I'm gonna make myself a chain. 1, 2, 3. I'm gonna 1, 2. So this is still the same as what I drew here. I'm gonna leave one of those as a methyl group and change one of them to a nitrogen group. And there we go. So it technically, once I added those other groups, it lost its hydrogen atoms, and the program already does that for you. We haven't been focusing too much on hydrogen atoms, and so I wasn't going to stress that too much. I was just going to let the program do it for you. All right. So we did this slide. All right, so next we have amides. Okay, so again, sorry, I messed this up here. This should say an amide. Okay. So we want to number a carbon. We want to make him the star of the show. So I'm going to start here. 1, 2, 3, 4. My amide group is in the same boat as aldehydes and carboxylic acids, where they're always going to end on carbon 1. Now, if you remember though, a few slides back, we talked about how you can have, let's go back here, how you can continue with an R group off of the amide, but the carbon chain will terminate. So you'll pick, say this side is longer, that's the chain that you would number, and you would not pick back up here, okay? This becomes a branch. So let's go back. So it's always at the number 1 carbon. All right, so this is bute because it has 4, and amide. And I don't need to tell the audience what carbon it's coming off of because it's always going to be coming off of carbon 1. There's no branches to take care of in this example, but we will in further examples. All right. So your AL question 14 is kind of complicated. Now, I wish that it didn't, it's a crazy example, but again, it was one of those where I didn't want to take it away because it was your only practice for amides, but they're kind of crazy examples, okay? But let's do them, because if I remember right, they don't have a huge question bank for this one, and I'm going to do 2 examples here, and those should definitely cover at least one, if not both of yours. All right, so let's start here. Let's call this structure A and B. Okay, so we have an amide group, but we have it coming off of a ring. Now, we talked about these rings in carboxylic acids. So anytime that we have a 6-member ring with double bonds, it's a benzene ring. So the benzene becomes our parent structure. So then I'm naming this ring 1, 2, 3, 4, 5. And so it will always come off of carbon 1. So the name of this structure is benz and amide. Okay. So benz because it's the parent structure, and amide because we have an amide group coming off of. All right. B here. This is kind of a crazy, outrageous example, but if we break it into its parts, it's the same as this first one, but now we have a group, a branch coming off of the nitrogen. This group just also it happens to be a benzene, but you know, they like to be complicated. So anytime this group is acting as in the parent chain, it's called a benzene, but when it's in the branches part, it goes by phenyl. So this structure is still, its parent chain is still benz and amide. But now we have to deal with this phenyl group, which is really just the same, coming off of the nitrogen. So if you remember right, nitrogen, anything coming off of the amine group in an am or an amide, we don't have a carbon number, but we say N. So this is N phenyl, benz, and amide. Now, I kind of forget, there's some like rules when you don't add the and it might be this one. So this might be benzamide. If it's giving you an error or something, try that. All right. Here's another. Oh, I forgot to change. These are 5 for you, not 14. But okay, so another crazy example. Well, actually, this one's kind of mild. So the first one here, I number from right to left, right? Because I want to make my amide the star of the show. There's no branches, so that means this is bute and amide. Here's kind of another crazy example. So my parent chain is going to be my longest chain here. 1, 2, 3, 4. All right, so now I have this same ring coming off of the nitrogen group, but we have an extra carbon. And of course, there's a special name for that. So when it goes carbon, then 6-membered ring with double bonds, it is called a benzyl ring. Love to be difficult. All right, so we still have a bute and amide, but we have to address this branch coming off. So it's N because it's coming off of the amide group, benzyl, bute, and amide. If I remember right, your exam doesn't have the, except for in the carboxylic acid example, it doesn't have all this benzyl versus phenyl versus benzene, but it does have groups coming off of the amine group. Okay. All right, so there's one reaction that we have to deal with amines. And so that is the reaction of an amine plus a carboxylic acid. And it is going to yield a amine salt. So in general, this looks like an amine group, connected to whatever else it is, plus a carboxylic acid group connected to whatever else it is. And then the reaction takes place. They usually need to add heat, and so sometimes that's depicted by the delta sign. And we get back water as a byproduct, but then these two structures merge together, okay? So you get back something that looks like this. All right, so you merge here. Let's see if I can use a different color. So you merge here, and you drop this OH and this one of these H's for the water. And so now you're connecting the amine group with the carbonyl group of the carboxylic acid. All right, so let's do a more specific example. All right, so I'm being very intentional with this example. So here we have an amine group between two carbons. And let's say this is going to bond to or react with this carboxylic acid. So we're going to do the reaction, add a little heat, get back water. So we're bonding here. We're basically going to drop this OH, drop this H. So I'm going to retain the structure of the carboxylic acid, but without the OH on it. And then it will become the N from the amine. And then I got to carry over whatever else is attached to the amine. So in this example, it's 2 methyl groups. Okay. So then there's only one question like this on your exam, but then it wants you to pick the answer from answer choices that aren't structures, but rather names. So the name of this, we're going to number here at the amide group. Oh, did I say amine salt? This should be amide salt. We're going to number here at the amide group, making the amide group the star of the show. And then we'll have to take care of these methyl groups. So this is prop, because it's a 3-carbon chain, and amide, because there's an amide group present. And then I will say NN dimethyl to take care of these branches. So I say NN, right? Because it's the same naming conventions as when we had something coming off of a carbon where we would say the number twice, but now we're just saying N twice because it's coming off the amine group. Dimethyl, because there's 2 of them, okay? So NN dimethyl propanamine. Whew. All right, so a few more slides here. Maybe only a couple. So important amines. So what I want you to take away from the slide is that our amines are the backbones for neurotransmitters. So norepinephrine has an amine group. Dopamine, serotonin has 2. Acetylcholine, here's an amine group. All right. Amphetamine, epinephrine again. Oh, no. The other one was norepinephrine. Here's epinephrine. Speed. All right, we like to throw little drugs in there. Okay. So amines are the backbone for neurotransmitters. Here is just a slide showing some more because I think it's interesting to see how almost similar sometimes nicotine looks to caffeine and morphine and codeine and heroin, how similar those all look. It's obviously so easy that somebody could get addicted to these structures, but this is more just nothing to memorize here, just hey, look, that's interesting. Okay. So topics from this lecture: be able to name ketones, we did that. Be able to identify aldehydes and name them. Know the test that distinguishes between ketone and aldehydes, Toland's reagent, right? We had a slide that talked about that. Be able to name carboxylic acids, specifically those on a benzene ring. We did those. Know the components of a saponification reaction. So there was a slide in there about that. Be able to name an amine. That was from this video. Know the properties of amines. Again, from this video. Oh, be able to name an amide. I'm sorry. Know the properties of amines. Be able to name the product of a reaction between an amine and a carboxylic acid. We just did that in this video as well. All right. That is the end of organic. We now move into more biochemistry, which the students really like.